heart went.
Welcome to another method in solving for networks or electrical networks, and we call this as mesh current analysis. So this mesh current analysis is also known as your loop analysis or Maxwell's method. So this gives us a general procedure of analyzing circuits using mesh current instead of branch currents. So dun sa Kirchhoff's, ang pinagbabatayan natin pag nagsosolve tayo ay yung kuryenteng dumadaan dun sa branches, right? But in mesh current analysis, what we're going to do is assume that there is a circulating current inside every loop. And these loops are known as your mesh. Okay? Remember that a mesh is a loop that does not contain any other loop within it. If we're going to look at this electrical network, this outer circuit that we have here may be considered a loop, but we cannot consider it a mesh. According to the definition in Maxwell's analysis, or Maxwell's method, a mesh should be a loop that does not contain any other loop inside it. So this outer circuit cannot be considered a mesh because there are smaller loops inside. So instead, this will be considered one mesh. Ito, isang mesh. Ito, isa ding mesh. So, parang kagaya ng sinabi natin nung nagki-Kirchhoff's tayo, yung mga windows ng electrical networks natin will be considered as loops. So, in this case, we will call them as mesh. So, dito ang idea, kung gaano karami yung loops or mesh natin, ganun karami yung equations na kailangan nating i-prepare. If you're going to recall, kay Kirchhoff, sinabi natin before, yung number of equations na kailangan natin nakadepende sa bilang ng branches. Okay, but in here, the number of equations that you need depends on the number of mesh that we have. So since this particular circuit has 3 meshes, therefore, we only need 3 circuits. So how are we going to apply mesh current analysis? Ano yung mga susundan nating procedure? Actually, in terms of numbers of equations that you have to solve, mesh is easier than Kirchhoff's because it only depends on the number of loops. But if you're going to notice the procedures we will be undergoing, parehas lang siya ni Kirchhoff's in terms of KVL, in terms of KCL, parehas lang. Ang naging iba lang dito is yung assumption ng current na gagawin natin. For me, it's best to assume mesh current first. So yung mesh current natin, yun yung circulating current inside every loop. And para hindi tayo marito sa kanya with branch currents, we're going to use lowercase letters for the variables we're going to use to indicate mesh current. So let's say we assume a clockwise circulating current here. Ganun din dito. And ganun din dun sa third mesh natin or dun sa third loop natin. Remember, pwede nyo itong i-assume kahit counterclockwise, walang problema ha. But for the standardizations of all our solutions, we're going to assume clockwise na lang. And then let me use small letter I here to mean mesh current and use a subscript A for this particular loop. So this particular loop has mesh current IA flowing inside it. This one, let's say this is IB, and let's say this one is IC. So after assuming mesh currents inside every loop, we proceed with KVL. And remember, the number of equations we need depends on the number of loops that we have. Okay, so let's start with KVL at loop IA. So, KVL tayo dun sa loop kung saan nagpo-flow si IA. Pag gumawa kayo ng KVL, parehas pa rin po sa Kirchhoff's, walang pinag-iba. Ang difference lang, ang titingnan yung kuryente itong mesh na to. So remember, nung nagki-KVL tayo, di ba, we trace it clockwise then. And since your mesh current is clockwise, then sabay tayo dun sa kuryente sa loob. So, ibig sabihin, yung voltage drop sa resistances ay negative kasi kasabay natin sila. So, let's do KVL. Let's start here. We have, pasok tayo sa negative, labas sa positive. That's why it's positive E sub 1. Okay? Minus, kasi kasabay natin. Pag nag-flow tayo dito pag nag-trace tayo dito kay R1, kasabay natin si mesh current. Parehas tayong clockwise. So, negative yun. Negative R1 IA. Pag ikot natin dito, we have negative R2 IA. After that, do not equate to 0 agad. Because this is a different method. So, after mo mag-KVL, okay, we're in obviously, palaging ang sequence niyan ay voltage, kung saang terminal lumabas, minus the sum of all resistors in the loop or in the mesh. And that's R1 plus R2. Multiplied by the flowing mesh current inside. Ito yung common sequence na mangyayari dyan. Kasi, if you factor out negative IA from here, you get negative IA factored out, you'll get R1 plus R2. So, para mas mapadali, hindi mo na ito susulatin ng isa-isa, pwedeng ganito na. You get your voltage minus the sum of all the resistors multiplied by the circulating mesh current. After that, since tapos na tayo mag-KVL, di ba? Kung babalikan nyo yung Kirchhoff's natin, tapos na tayo. But this time, this is mesh. So, do not forget na after mo matapos yung loop, you have to add the so-called mesh current effect. Okay? Mesh current effect. Okay? Merong branch dito sa loob ng mesh na to. May branch sa loob ng mesh na to na nakaka-experience ng effect ng isa pang mesh current. And that is R2. R2 is in between two meshes. Ibig sabihin, it is affected by two mesh currents. You have IA on its left and IB on its right. And since there's a mesh current effect here, di ba dito tayo naglo-loop sa IA, pero apektado siya ni IB, you have to add the voltage drop due to the effect of mesh current IB. So that would be current times resistance. You have IB R2. Laging tatandaan, mesh current effects are always positive. Okay? After that, pag nalagay mo na, kay R1 wala tayong ilalagay na mesh current effect kasi wala namang kuryente dito sa taas. So after that, you're going to equate this to 0. Okay? And then simply arrange the equation that you have. So this could be negative of R1 plus R2 multiplied by IA plus R2 IB equal to, if this is constant, we transpose it to the right, that's negative E sub 1, and this will be your equation number 1. After that, we take our loop here, we KVL at this loop, at IB, so KVL at loop IB, ganun lang ulit ang gagawin nating steps. Ano po? So, since wala namang voltage dito, ibig sabihin, negative na. Diba? Kasabay natin yung kuryente kasi so lahat negative na. Negative of the sum of all resistances inside the mesh, and that's R2, R3, and R4. Multiplied by, anong loop ito? This is IB. After that, i-observe mo kung mayroong mga resistors na naaapektuhan ng ibang mesh current. Of course, we have R2 and we have R4. So, i-add natin yun. We're going to add mesh current effect of IA kay R2, and that would be R2IA plus, meron tayong isa pang mesh current effect because of IC, naapektuhan niya si R4. So, we'll get an IC, an R4 IC, and then after all the mesh current effects, you equate that to 0. So, ito yung equation natin. Dinugsong ko lang dito. And this is equation number 2. But if you want, we can rearrange first. So, let's arrange in the sequence ABC. So, we have R2 IA minus R2 plus R3 plus R4 IB plus R4 IC. Equate it to 0, and this is your equation number 2. After that, maglulup na tayo dito sa patatlo. So, we're going to do KVL at loop IC. So, we have here negative sum of all resistances sa loob, R4 plus R5, multiplied by mesh current sa loob. Tapos, pasok tayo sa positive, labas tayo sa negative terminal ng voltage. We have negative E sub 2. Tapos na ako sa loop ko, pero meron akong mesh current effect because R4 is affected by IB. So, magkakaroon ako dito ng plus R4 times mesh current IB. And then, equate that to 0. Okay, so we're going to rearrange again. This will be R4 IB minus R4 plus R5 IC. And then if this is constant, we transpose it to the right. So let's assume it's constant. Positive V sub 2, and there you have it, your third equation. So yung tatlong equations natin po ay ito, at ito. So with 3 equations, 3 unknowns, kuha natin agad yung value ng IA, IB, and IC. Okay, so kung tapos na tayong mag-KVL from 3 loops, and you now have 3 equations, we can use our calculator for that, and you will get an answer for IA, IB, and IC. Di ba? Magkakaroon na tayong sagot dyan. After having answers for the mesh currents inside every loop, anong sunod natin gagawin? My advice is, after mo mag-KVL and after mo makuha yung value ng mesh current, saka ka mag-assume ng directions for branch currents. Yung branch currents, yun yung mga kuryenteng ina-assign natin nung nagsosolve tayo using Kirchhoff's, nanda pa ba? Ngayon, bakit hindi ko yung ginawa agad? Para hindi kayo malito. Kasi baka mamaya, yun ang tingnan nyo pag kayo ay nagki-KVL dito. So, para hindi kayo malito, huwag nyo munang ilagay, since wala pa naman tayong paggagamitan ng branch currents na yon. And then, pag nakuha nyo na yung mesh current, saka nyo na lang ilagay yung assumption nyo na direction for branch current. Kailangan pa bang magkaroon ng assumptions for branch currents? Of course, kasi ang idea for network analysis is to be able to understand how the current flows and what are the values in every branches. Okay, so kailangan mag-assume pa rin tayo. Now, let me write down the assumption we have in our PowerPoint presentation. So, kokopyahin ko lang yun We have here I1 flowing through R1 and it's on the right direction. We have an upward current here that represents I2. And then you have a rightward current here, that's I3. And then downward naman dito, si I4. Saan ba? I4. And then we have to the left. So, ibig sabihin galing yun dito, papunta dito. And this is your I5. Okay. Next. After mo ma-assume yung directions ng branch currents, anong sunod natin gagawin? Ang sunod natin gagawin ay mag-inspect. So, by inspection, what do we mean by inspection? Kasi po, meron ka ng values for IA, IB, and IC. So, ito, may mga value na yan. Ngayon, if we're going to notice by inspection, ang assumption natin ay ganito. If the particular branch has only one mesh current flowing through it, ibig sabihin, kung ano man yung branch current doon, which is I1, yun na rin ang value ng mesh current na nandun, or vice versa. Kung ano man ang mesh current dito, since siya lang naman yung kuryenteng umaapekto sa branch na to, kung ano man yung kuryente sa branch na to, pareha siya ng value ng mesh current na nagfo-flow doon. So, ibig sabihin, if this branch has I1 flowing through it, and it is affected by IA only, in short, iisa ang value nilang dalawa. Okay? Now, what are the assumptions of the signs? If I1 and IA are in the same direction, then they are equal and positive in sign. So, in short, since aray pa kanan at ang ikot ni IA ay clockwise, ibig sabihin sabay sila, kapag sabay, positive. Therefore, by inspection, yung IA mo na nakuha, equal na yon sa positive I sub 1. Now, anong pwede nating sabihin tungkol kay IB? Si IB, it affects 3 branches. This branch, and this branch. Each of the branches have different currents. This is I2, ito ay I3, ito ay I4. Ang kaso, hindi natin pwedeng sabihin, kagaya ng nangyari kay IA and I1, hindi natin pwedeng sabihin na si IB ay equal kay I2 or si IB ay equal kay I4. Bakit po? Dahil itong dalawang branch na to, they are affected by 2 kinds of mesh current. So, si I2 branch, affected siya ni IA at ni IB. Si I4 branch, affected siya ni IB and IC. So, hindi yun equal. Saan mag-i-equal si IB? IB will be equal to this branch. Kasi itong branch na to, iisa yung mesh current na nakaka-apekto sa kanya. And therefore, we will say that IB is equivalent to I3 na. And since I3 is pa kanan, the mesh current IB flows clockwise. So, pagdating niya sa side na to, pakanan din si IB. Ibig sabihin, equal sila with positive sign. So, IB is simply equivalent to positive I sub 3. Okay? Next, punta tayo kay IC. Pagdating natin kay IC, meron tayong two branches that IC affects. It affects this branch, which contains I4, and it affects this branch, which contains I5. And again, we cannot say that IC is automatic equal to I4 because I4 is affected by two mesh currents. Instead, since IC is the only mesh current that affects I5, ito lang yung mesh current na nakakaapekto or dinadaanan ni IC. Ibig sabihin, equal sila. But if you're going to notice, IC is clockwise. Kaso yung kuryente dun sa branch ay pakaliwa. Di ba pag dumaan dito, sa side na to yung mesh current natin, pakanan siya. Pakanan si mesh current, pero yung branch current mo, pakaliwa. Magkasalubong sila. So pag ganun po ang nangyari, if they are in opposite directions, if the mesh and the branch currents are opposite in directions, then one is equal to the negative of the other. So ang mangyayari dito, IC therefore is equivalent to the negative of I5 or vice versa. Pag pinag-transpose natin, ibig sabihin your current I5 is simply equivalent to the negative of your IC. So kung ano man ang values ng mga to, substitute lang natin. So ano nangyari? After 3 kVs, nakuha mo to, nag-inspect lang tayo, and by inspection, meron na tayong tatlong kuryenteng na-solve. And those are I1, I3, and I5. So mas madali. Afterwards, pag okay na tayo dun, meron pa tayong tirang dalawang branches na kailangang isolve kasi nawawala pa si I2 and si I4. For that, we will use KCL naman. Now, how do we do KCL if we are under mesh analysis? So, ang gagawin natin ay ganito. Let's assume names for our nodes. So, let's say this is node A, this one's node B, this one is node C, and this one is node D. Since ang nasolve na natin ay I1, I3, and I5, base dun sa inspection kanina, meron na tayong sagot para sa mga ito. So, anong kulang? Ang kulang ay si I2 at si I4. Ngayon, kung magki-KCL ka, ang target palagi natin ay yung kuryenteng nawawala. So, since nawawala si I2, if we're going to KCL for I2, ganito ang gagawin. Kuhanin niyo yung branch. I'm going to take that branch. Copy the nodes. That's A and C. This is R2. And it has an upward flowing current I2. Pag nakuha mo yung branch, kuhanin mo din yung mesh currents that affect the branch. We have two. It's affected by IA and IB. So, dito si IA. Dito sa kabila si IB. Okay? At ito ang tatandaan. Kapag yung branch po na kinukuhanan natin ng branch current ay vertical, nakatayo, ibig sabihin, ang mesh currents niya ay nasa kaliwat kanan. Okay? Pag nag-KCL ka at node A for I2, we will assume that at node A, this mesh current enters the node. While at IB, this mesh current naman at node A leaves the node. Para kasing ang assumption dito is, while this is circulating, this current here has the tendency to enter that node. While this one has the tendency to ignore that node naman. Parang ang behavior kasi ng current dito ay, kung alin yung nasa kanan niya, dun siya papasok. So parang ang mangyayari, kung dito ka magno-node, ito, since pag-ikot nito ay tatamaan ni IA sa kanan si node A, papasok siya. While IB, pag umikot ito clockwise, ang kanan ni IB ay ito, di ba? So, ibig sabihin, yung kaliwang side, which is node A, i-ignore niya yan. Which means, aalis or it will leave the node. Ngayon, ang gagawin natin dito is, observe IA sa taas. IA is entering, so it will be positive. Ganun pa rin, same. Kung papasok, positive. Kung lalabas, negative. Okay? And then this branch has I2 flowing through it and I2 is upward. So, kung titingnan mo yung direction ni I2, papasok siya sa node A, kaya positive I2 yun. While IB, sabi nga natin, yung nasa kanan, papasok siya sa kanan. So, yung kaliwang side niya, which is node A, aalis siya doon. So, negative si IB sa node A. and then simply equate to 0. So from here, we can solve for I2, and I2 is simply equivalent to the negative of IA if you transpose it to the right, and positive IB. But since we have answers for IA and IB, di ba na-solve na natin sila kanina, you will simply substitute here, and then you'll get an answer for I2. Okay, ito ang tanong. Kailangan ko po bang i-redraw palagi ang branch kung saan hinahanap ko yung current na nawawala at kopyahan ng mga mesh current ito? Hindi po. Ginawa ko lang to for illustration purposes. Kung sanay na kayo, dito nyo na lang tingnan sa circuit mismo. So at this circuit, ito din naman yun eh. At this circuit, you have this mesh current. O yun, sa kanan niya. Papasok si IA. Basta tatandaan nyo, pag vertical ang branch, yung nasa kaliwa, papasok sa taas. Yung nasa kanan, lalabas. Okay? Pero pag dito ko tumingin, so mayroon, pag umikot ito, papasok si IA, di ba? Papasok si IA dito. Pag umikot yan, lalabas siya sa C. Tapos ito naman, papasok siya dito, lalabas siya sa baba, papasok ulit siya dito. So nagbaliktad. Si IA, papasok sa A, lalabas sa C. Si IB, lalabas sa A, papasok sa C. Ganun yung sequence. Okay? Ngayon, paano kung pwede po bang wag nang i-redraw ito? Opo. Dito ko na lang tumingin, yun din naman yun eh. Tandaan nyo lang yung mga palatandaan na sinabi ko. Okay? So, IA here is entering, IB is leaving, I2 is entering. So, ito pa rin makukuha may equation. I showed you this because this is a KCL using mesh currents. Pero, pwede ka pa rin mag-KCL using branch currents naman. Kung nalilito ka kay IA, kay IB, pwedeng sa branch ka na lang tumingin. Kumbaga, kung anong ginagawa natin sa Kirchhoff's before, yun ang gawin mo. Pag nag-KCL ako at node A, tingin ka sa branch current, o tingin ka sa linyang nakakabit kay A, so I1 papasok, I2 papasok, I3 lalabas, so negative I3, equal to 0. Ano nga yung inspection natin kanina? Ang inspection natin kanina is I1 is equal to IA, I3 is equal to IB, and I5 is equivalent to negative IC. Okay. Try natin i-substitute. If I replace I1 with IA, plus I cannot replace anything with I2, minus I3 palitan ko ng IB, equate that to 0, lalabas pa rin itong equation na to. Nakita? Etong equation na to ay ginawa ko looking at the mesh currents and the unknown current I'm solving. While this equation, I made it using the branch currents. But, kapag nag-substitute tayo, lalabas iisa lang ang equation yon. So, you have two options on doing your KCL. Kayo po ang bahala, whichever is convenient. Ma'am, pwede bang kalimutan ko na to kasi nakakalito? Hindi pwede. Bakit? Because there are circuits that are easier to solve. Since this is mesh analysis, we have to use the mesh current. May mga circuit na mas madaling isolve kung naiintindihan mo how the mesh current works. Kasi kapag sa branch tayo tumingin, napakaraming KCL ang gagawin para lang mabuo natin yung hinihingi ng mga equations para sa atin. So, hindi pwedeng mag-stick lang tayo sa isa. We have to know lahat iyon. Tapos saka ka na lang pumili kung saan ka convenient. Okay. Ma'am, paano pag sa C naman ako nag-KCL? So, halimbawa, I'll do KCL at node C. I'm still solving for I2. Diba? So, ito yon. Okay. So, sabi ko nga kanina, if your branch is vertical, yung mesh current sa left, sa taas papasok, sa baba yung lalabas. And yung mesh current sa right, sa taas yung lalabas, sa ilalim yung papasok. So, pag dating mo sa ilalim, pag dito ka nag-KCL, mababaliktad ang sequence. So, mangyayari, at node C, IA is leaving, kasi papasok yun dito, tapos lalabas sa ilalim. So, IA is leaving, that's negative IA. At node C, I2 is leaving, di ba? Pataas. So, negative I2. And then, IB, sabi natin kanina, dito mo tingnan si IB. Si IB ay papasok sa B, lalabas sa D, papasok sa C. Labas-pasok lang naman yun eh. So, papasok to sa node C, positive IB yun. Equate that to 0. If you try to transpose this to the right, it will become positive I2. So, you'll have here equal to positive I2, tas ito yung tira sa kaliwa. Pinagpalit lang natin, that's negative IA plus IB. And if you're going to notice, yan. Same equation siya na makukuha mo kahit saan ka mag-node. This is how you're going to solve for I2. So, ibig sabihin, meron na akong I2. That's negative IA plus IB. This time, kunin naman natin yung I4. Okay lang ko pa bang i-cut si I4? Pwedeng hindi na, di ba? Dito na lang ako titingin. So, if I'm going to do KCL, I can do KCL at node B for I4 para ma-solve ko si I4. And if I KCL at node B, tanda ba? Vertical to. So, yung nasa kaliwa, papasok sa taas. Positive IB. Papasok si IB sa taas. Paalis. From node B, paalis si I4. So, negative si I4. And then, yung nasa kanan, lalabas yun sa taas, diba? Leaving. So, negative yan si IC. Equate to 0. Or, if you want, you can look at the branches naman. If you take KCL at node B, using the branch currents, you have positive I3. Papasok yun sa B. Aalis si I4, so negative si I4. And then, I5 is entering, so you get positive I sub 5. Equate to 0. Now, let's try to substitute in this branch current equations yung assumptions natin or inspections natin. So, isa-substitute ko to dito para makita nyo na parehas lang yan dito. So, I3 is equivalent to IB. So, I'll have here IB minus I4. And then I5 is equal to negative IC. So that would be minus IC equal to 0, which means this equation here is just the same as this one upon substitution of the inspection. Parehas lang. Okay. What if I KCL at node D? So if I KCL at node D for I4 and I'm going to use the mesh currents, sa ilalim, yung nasa kaliwa ay lalabas. So negative IB plus, papasok si I4. Tapos, papasok si IC. Yung nasa kanan sa baba naman yun papasok. So, positive IC equate to 0. So, if you're going to notice, this is the same as this one if you try to transpose. Okay, so if I transpose this two to the right, I'll get I4 equal to positive na si IB and then negative si IC, which is the same as this one if you transpose I4 sa kanan. Diba? If you transpose I4 sa kanan, magiging positive siya. Same nito. At ang nasa other side niya ay IB minus IC, which is also this one. Which means, to solve for I4, it's simply IB minus IC. And this is how you're going to solve all the unknown branch currents using the mesh current analysis. Okay, so yung ginawa natin ng KCL kanina, yun ay mga branches na nakatayo. Vertical branches with mesh currents on its left and right side. Paano kapag yung branch ay nakahiga? Halimbawa lang, hindi ito yun ha. Halimbawa lang, meron kang branch na nawawala ang branch current niya. Let's say yung branch current na yun ay CI. Tapos may nodes siya, let's say node X and node Y. Let's say meron ditong mesh current sa taas and mesh current sa baba. Siyempre, kapag vertical ang branch, kaliwat kanan ng mesh current. Kung horizontal ang branch, taas baba yung mesh current niya. So, let's say this is IA and this is IB. Paano tayo magki-KCL? Ano ang magiging assumption natin? Okay? So, if you're going to KCL at node X for I, para ma-solve mo si I, ganito po ang assumption. Etong mesh current sa taas, ano sabi natin? Sa kanan ng pasok, di ba? Dito ngayon papasok sa Y. IA leaves X, lalabas siya sa X, papasok yan sa Y. While IB leaves Y, papasok yan sa X. So you have to imagine yourself being the arrowhead, and when you turn, you have to decide alin yung kanan mo. Dito kasi sa ilalim, si arrowhead, itong arrowhead na to, ang right niya, di ba ito left to? Ang right niya ay ito, si X. So, dun siya papasok. So, yung mesh current sa taas, papasok yun sa kanan, lalabas sa kaliwa. Yung mesh current sa ilalim, lalabas yun sa kanan, papasok dito sa kaliwa mo. Okay? So, pag nag-KCL ako node X, that would be negative IA. Based on branch current I, it's negative kasi palayo siya kay X. And then for IB, papasok yun sa X, so positive IB. Equate to 0. If you're going to KCL naman at node Y for I, para ma-solve mo si I, sa kanya naman papasok si IA, positive. Papasok si I sa kanya based on the direction of our assumption of the branch current. While IB, aalis naman siya kay Y. So, negative naman si IB dyan. If you're going to notice, these two equations are the same if you try to multiply this by -1. Both sides. So this will be positive, this will be positive, this will be negative, still 0. So parehas lang. And that's how you do mesh current analysis.